concavity and inflection points. Sometimes I call inflection points P's OI for points of inflection, in case you see that shorthand. Now recall that f double prime of x, or d squared y over dx squared, is the derivative or slope of the derivative of y equals f of x. That is, it's the second derivative, also known as the rate of change of the rate of change. We want to talk about two ideas, concavity and points of inflection. Let's start by looking at a big graph of f of x. And on this graph, we're going to plot some values of f prime. And let's start by finding where f prime equals 0, or at least approximate. Certainly when the graph of f changes from increasing to decreasing or vice versa, we know that f prime equals 0. So let's label those points. Now at a few points, let's say here, 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 all of these, we're going to find some values of f prime. And we're going to guess at them, and we don't have to be correct, but we need to be relatively correct. So at this first point over here, I'm going to say that f prime is, well, maybe 3. Certainly it's positive since f is increasing. And at this next point here, I'd say that f prime is perhaps 1. Now you could have said 2, you could have said a half maybe, but you can't say f prime is 4 because f is flattening out. That is, the slope of f is getting smaller or decreasing. And then I'm going to plot some values over here, and then, again, I don't need to be correct, but just kind of relatively correct. And let's see if you agree with my values as I write them. Just plug in the values. What I think f prime might equal based on the other values that I chose. And I'll keep going just a little bit while longer. Something like that. Do you agree with maybe not the values, but at least that they're correct relative to each other? And then I have some questions to ask you. On the interval, here to here, this entire interval, what can you tell me about f prime? Well, f prime is not positive on the entire interval, nor is it negative, but I do see that f prime is getting smaller, that is, f prime is decreasing on that entire interval. Well, if something is decreasing, where f prime is my something, then the derivative of that something, in this case f double prime, is negative. Right? If something is decreasing, its slope is negative. Let's take a look on this next interval, so starting right there and going all the way over to here. So on this entire interval, what can you tell me about f prime? Well, it's not negative on the entire interval, nor is it positive, but on that entire interval, I do see that f prime is getting bigger. That is, f prime is increasing. And if anything is increasing, in this case f prime, then its slope is positive. And then once again, on this final interval, we see that f prime is decreasing, so f double prime is negative. Now notice on this first interval over here, where it almost looks like you're frowning, we say that f is concave down. So either these, f prime decreasing or f double prime negative, tells us that the function f is concave down. On the next interval, where it looks like f is smiling sort of, we say that f is concave up. So f prime increasing or f double prime positive both indicate that the function f is concave up. The places, that is the points, where f prime changes from decreasing to increasing or vice versa, these 2 points, we call those inflection points of f. There's one there, and we have another one on the right side of the graph. To formalize it, the points where f prime changes from increasing to decreasing or vice versa are the inflection points of f. When we're doing algebraic problems, it is a typical justification for an inflection point to show that f double prime changes signs. That is equivalent. Don't make the mistake of saying f double prime is 0. We have to say that f double prime changes signs or show that it occurs. Let's start with an algebraic example. Consider f of x equals x cubed over 3 minus 6x squared plus 8x plus 2. We want to find the intervals where f is concave up, concave down, and find the inflection points of the function f. Let's look at the keywords or phrases. Concave up, concave down, inflection points all tell us we need to find f double prime of x, generally speaking. We could do inflection points with f prime increasing or decreasing, but we usually use f double prime. We, of course, need to start by finding the first derivative. So we'll do that. We get x squared minus 12x plus 8. That'll help us find our second derivative, f double prime, which is 2x minus 12, or 2 times x minus 6. Like we did with local extrema, I'm going to build a sign chart, but this time with f double prime down here. I'm going to plug in the zeros of f double prime, in this case 6, and then we'll test values on either side of 6. So when x is, say, 0, we get f double prime is negative. Don't need to know the exact value, just that f double prime is negative, because all x values on this interval will give f double prime negative. Choose any x value greater than 6, let's say 8. I see that f double prime is positive. Notice I'm just sticking into here. So on the first interval, I could see that f is concave down. And the next interval, I see that f is concave up. So I like to draw these shapes, kind of a frown and then a smile like this. So where is f concave down? I'll abbreviate as conc down. Very easy to see. From negative infinity to 6. Why? Because f double prime is negative. F is concave up. Where? Well, from 6 to infinity. Because f double prime is positive. How about the inflection points? Well, there's one. The inflection point is at x equals 6. Why? Because f double prime does what? Doesn't equal 0. I mean, it does, but that's not the justification. It's because f double prime changes signs. One more example. In this case, we're going to do a graphical example, but I'm going to do it in a couple stages. Let's pretend that this is a graph of g prime, not g. And I want to find the following information. Where is g concave up? Where is g concave down? And where does G have inflection points? Now, all of these keywords, concave up, concave down, inflection points, say I need to look at G double prime somehow, or maybe where G prime is increasing or decreasing. So let's look at the underlying truth first. G is concave up when G prime is increasing or G double prime is positive. They mean the same thing. So I look at my keyword or phrase, I find the truth, this is always true, and then I go back and look, well, how do I find that? Well, it's pretty easy now. I need to find where G prime, which I've been given, is increasing. That is, where is it going up? Reading from left to right is from negative infinity to negative 1. Is there any other place where G prime is going up that is increasing? Sure, from 1, 2, 3, 4. If I can count correctly, 1, 2, 3. I can't count correctly, so I will fix it here. From x equals 1, 2, 3 to 5. Now, where is G concave down? Well, the underlying truth of that is when G prime is decreasing or G double prime is negative. So I already know what to look for. I look for where G prime is going down or decreasing. And that's on the interval from negative 1, starting here to 3, and also on the interval 5 to infinity. Where does G have inflection points? I already know that's where G double prime changes signs. I'll put CH for change. Or where G prime changes, I'll write it out here, increasing to decreasing, or decreasing to increasing. In other words, G has inflection points at the local maxes and mins of G prime. So where? Right there, and right there. At x equals negative 1, 3, and 5. Well, now let's do the same thing. Let me get rid of these answers here. We'll do the exact same thing. That is, find the exact same thing. But now let's pretend this is a graph of G double prime. Same graph, but we're going to call it something different, G double prime, and we're asked the same questions. Where is G concave up? Underlying truth, G is concave up when my second derivative is positive. Where is G double prime, the graph that I can see positive? From there to there only, on the interval negative 3 to 1. Where is G concave down? When G double prime is negative. That's the truth. Now I can look and say, well, I have G double prime. Where is G double prime negative? Well, first of all, everywhere up to negative 3. And then from 1 all the way to 5. And then starting again on the other side of 5. Because at x equals 5, G double prime is 0. Where does G have inflection points? Is that where G double prime equals 0? Usually, but that's not a justification. It's where G double prime changes signs. That is the justification we need to use. So where does G double prime change signs? Well, right here where it equals 0. Okay, so at x equals negative 3. Right here where G prime equals 0. So at x equals 1. And right here, G double prime equals 0 at x equals 5. But notice that G double prime does not change signs, so that would not be an inflection point of G.